Hello, thank you very much for being here. Today we will talk about the decoding of NetOP temperature humidity sensor. Here is our decoding document. You can find it on our wiki page. And today I will show you two different payload protocol. One is about a live message, which contains device information such as battery information. And the next one will be about the data for temperature and humidity. Let's start with the first one. So as a first, let's open the payload decoding document and start with frame. Here is our raw data which we receive from the device, and according to frame format, first byte is about protocol header, and as you can see, first byte is protocol header, and next 4 bytes will be about serial number. So here is serial number, and after that there are some data blocks. It depends on the message, but at the end of the day we have 1 byte checksum. So 1 byte checksum here, and before that data block or data blocks. We will give more information about this part, data blocks, on next one, so it will be much more clear. So we use frame section and decode the raw data section by section, and we have data blocks right now. So let's continue with data blocks. So on section 4 data blocks, it says first 3 bytes is data header, and next ones is for data payload. So first 3 bytes data header, and next one is data payload. So we need to continue with data header right now. So let's deep into data header one. I am opening the data header section on the PDF, and as you can see, it contains 3 bytes, and there is more information about what does it mean, these 3 bytes, as binary format. So we need to transform these hex to binary to understand what does these characters mean. So transforming hex to binary, we have this format, and let's do it one by one according to the document. First character from left to right is for timestamp. So here is a timestamp is 0 for this case, and you can find more information about the timestamp on section 411. Let me quickly show you here, and let me go back. Next one character is for result, so 0 is result, and next 3 character is for slot number. For our case it is 0, so slot number is 0, and please go to section 412 for more information about slot number here. And it says that if this field is 0, it means that it is about complete device information. So we are here. Next one character is for data payload error, so it is 0 for our case. And next non-character is for sensor function or device information. For this example, we have it from here. This is binary, so we need to transform this binary to hex to find what is our sensor function. So translating from binary to hex, it is equal to 10. And referring to section 414, I would like to get your attention on this part because here is important. If sensor board type is 0, so let's have a look our case. Sensor board type is 0, yes. So we need to open table 7. So opening table 7 now. And our hex is equal to 10. 10 here is for battery level and payload length is 1 byte. So briefly, our sensor function is equal to battery level, and we will have 1 byte information about battery level after this loop. So let me continue. Next 1 byte is for reserved here after sensor function, and next 1 byte, next 8 character is for sensor board type. And also you can find more information about sensor board type at section 415 here. So you can kindly skip this part because when we go to sensor board type section, it says that if this field is 0, yes, it is 0 for this example. That means the following information is about sensor function device information section. So let's open sensor function. And for 0, it means nothing for now. So we complete data header and we understand what we will receive after this loop. We will receive 1 byte and it will be about battery level. So this 1 byte is this one, 64, and it is hex. And to have more information about battery level, we need to go to section 6.17. Let me search it. Yeah, here. And it is decimal value, so we need to translate hex to decimal, and when we translate this to decimal, it is 100% battery level. This is first part of this decoding example to decode device generated information for battery level, and let's continue with second one. Here is another format, and as you can see, this data length is longer than first one, as you can see. So let's do the same as we did on previous example. We need to start with frame, and for this case the structure is same, 1 byte for protocol header and next 4 bytes for serial number, and next one is for data blocks, and last one is for checksum. We need to continue with data blocks. So let's open the data block section on the PDF. It says 3 bytes data header and others for data payload. So 3 bytes data header and others for data payload or NIV data blocks. Let's continue with data header to have more information what we will receive from the device and what we need to do. So refer to 4.1 for data header. First character will be about read timestamp, it is 0, and next one is about result, and next 3 character is for slow number, it is 0 for this case, and next one payload error, it is 0, meaning that there is no error about received data. The data is received well. And next 9 character is for sensor function or device information. Let's translate this. It is equal to 10 in hex. And when we look at the table on sensor function, it is equal to battery level. We already have look at this part on previous example. So it is equal to 100 and it is the percentage of battery level. So after that we complete data header part for this part, and we understand that first data after this data header is about battery level, and this one is about battery level. But now we have one more data blocks right now, and it is new data block. So we need to do same, and we need to decode these data blocks as a first. So let me open data block. We know that first 3 bytes of data blocks is for data header. So first 3 bytes is data header, and next one is for data payload in our live data blocks. Let's go deep into for data header. We need to translate this hex to binary and understand which character is for timestamp result slot number. For this example, timestamp is 1, and it means that after this data header, after this loop, first 4 bytes will be about timestamp, will be for timestamp. And result slot number 1 sensor function. When we translate binary to hex, it is equal to 0 Bravo, and it means that temperature humidity sensor. We can find it here. Sensor function 0 Bravo temperature humidity, and it says that 3 bytes. So meaning that after this data header, after this loop, we will have 3 bytes, and it will be about temperature humidity. It will be for temperature humidity after timestamp. So next is result, and final one is for sensor board type, which is also equal to 05 in hex, and meaning that temperature humidity sensor board. So we have complete data header part right now, and let's continue. And what we understand from this part, it says first 4 bytes of data payload, meaning that this one will be for timestamp, and after that next 3 bytes will be for temperature humidity. So first 4 bytes of this data for timestamp, meaning that timestamp is 0, and next 3 bytes is this one, and it is for temperature humidity value. So let's go to the temperature humidity function on the PDF. We can quickly find it as here. As you can see, there are 3 bytes for temperature humidity information, and from here to here is for temperature information, and last 10 character from right to left side is for humidity. So briefly, this side will be for temperature, and this one will be for humidity information. And let's have a look how to calculate temperature and humidity. For temperature, we need to subtract for 1000, and then we need to divide it by 100. So when we transfer from binary to hex, we will have this value as decimal, and then when we minus for 1000 and divide it by 100, the final value will be 25.75 degree Celsius. And about humidity, all we need to do is dividing by 10. So when we transfer binary to decimal, which is equal to 573, and divided by 10, which is equal to 57.3% humidity. So this is all about the coding part. When we look at the big picture, what we understand from the message is that we know that the battery percentage of the device regarding its last data, and the battery level is 100, and also temperature information is about 25 degrees Celsius, and also humidity is about 57%. Thank you very much for your interest, and if you have any question, please do not hesitate to contact us.